sequence is a function whose domain is a set of positive integers. So the difference between functions that I've been dealing with and a sequence is the domain. Instead of just thinking of something like the x-axis number line going from positive to negative infinity and being anything in between, could be 1/2 here minus the square root of 2 over 3 or something. The domain of sequences are positive integers, so 1, 2, 3, 4, 5. It's just like counting outwards to positive infinity. So that being said, the notation isn't too much different. Here's an example of a function. If I were to take it as a sequence, then the notation changes from x to n to kind of emphasize the fact that these are positive integers. N, I think of number. So I'm putting in numbers 1, 2, 3, 4, 5, however many I want the sequence to have. And the only other thing is that f of n is replaced by an. And an is what number in the sequence I want. So if I were to start plotting points for this sequence, I would get 1, n is equal to 1, so that's kind of like I think of my x, forget about x, just think of n. N is 1, 2, 3, 4, 5, just keep counting, 1, 2, 3, 4, 5, and then these are my output values, 1, 1/2, 1/3, 1/4, 1/5 for this sequence right here. So what this is saying is a to the n, which term of that sequence do I want? So if I want a, let's see, say the fourth term of the sequence, a4, it's 1 over 4. I just put in 4 wherever there is an n. And 1, 2, 3, 4, that is the fourth term of my sequence. So that was a simple example. I'll just do another couple examples, I suppose. Suppose I have, just make up some sequence, 2, 4, 6, 8, 10. So I want to use my new information and write, and this continues. So I want to use my new notation and write a sequence for this. Well, this increases by 2 every time, so 2 is my first term of the sequence, then 4, then 6, then 8, so it just increases by 2. So this is a pretty easy one, 2n. It has to go by integers, and in this case, unless stated otherwise, it's always going to start at 1. So I need to make this series or sequence correspond to some formula, and this is the easiest way to do it. 2, if I put in 1, I get 2 for this. If I put in 2, I get 4. If I put in 3, I get 6. So let me do one more. Let's just take this one and then change it a little bit. Let's say I have 1 and how about minus 1/2. So this sequence is almost the same as this one, except it alternates between positive and negative. So it's pretty obvious that this is going to be a part of it somewhere. So I've got this, but then how do I make this change from positive to negative on alternating numbers in the sequence? Well, I can accomplish that by multiplying it by a minus, and in order to make the odd numbers of the sequence, so 1, 3, 5, it's going to need to be balanced out to be positive on those ones, and then this is going to have to be negative on the even terms of the sequence, minus 2, minus 4. So what I can do is do n plus 1. So the only way this will change, the only thing that's going to change here is just the minus sign. On odd terms of the sequence, this will add to be an even number, because an odd plus an odd is going to be an even. I could put 3 if I wanted, doesn't matter. Odd plus an odd is an even. So this will be even and therefore positive. And then on the even numbers of the series, an even plus an odd is an odd, always. So, on the even numbers of the series, it's going to be a minus 1, because a minus to an odd power will be a minus. So those are a couple very quick series examples.